So we'll start with this. Alright, number 5 says f of x is equal what? Sine x. And we're using the point 2, the sine of 2. And that's kind of a cop-out because it doesn't actually give you the value for this. So my c is 2, my f of c is equal to 2, which will help with the linear approximation. Now I need to find f prime of x, which is what? Derivative of sine is cosine. So it's the cosine of x. Do I have to do a chain rule on the x? Alright, no. That's good. Now, I need f prime at c. Alright, what's my c value? 2. So I'm going to get the cosine of 2. Now, the reason why, let me make that a little bit brighter. What we're doing here is, that's an exact value. So we're going to keep it as an exact value. And now that we want f, or y, this is going to be our linear approximation slash tangent. Y is equal to f prime of c times x minus c plus f of c. So y is going to be equal to the cosine of 2 times x minus 2 plus the sine of 2. And I'm going to leave it just like this, because now it's just plugging in numbers and all that and all of that. So this linear approximation doesn't look anywhere near easier than the actual value, the actual function itself. But are we okay with that being the function, or that being the linear approximation, the function being sine x? Alright, so now let's see how good it is. So I'm going to start up Microsoft Excel so you guys can see how this one works. And one point nine, 1.99, 2, 2.01, 2.1. Now I want this to be f of x, and this is the tangent of x. So we're going to have to build in this case. So the first, I use a lot of parentheses. Start with an equal sign. We're going to do a cosine of this value, correct? Alright. And that's going to be times this value. It would be cosine 2. Alright, so that's the slope, cosine of 2, times the x value minus 2, which is here. And then we're going to have to add on the sine of 2. And I got that value. And the nice thing is, once I've created this, all I have to do is drag this down, and I got all my answers. Yes?
Oh, wait, okay.
A3 is here. That's my x value. And now the cool thing is, well, that's not, this is actually t of x. And this is f of x. f of x is what, just equal to the sine of that, right? And now I'm beginning to wonder, alright, maybe this isn't the best way to do it. I like this. That seems to work pretty good, but this one doesn't seem to work all that good. But that's how you would end up doing something like that in Microsoft Excel. I'm actually going to jump into here. I'm going to use the calculator because I think the calculator might be actually a little bit better for this. Make that a little bit bigger. We'll call this D. Just picked one. 1.9, 1.99, 2, 2.01, 2.1. And then this is going to be equal to cosine of 2 times D minus no, it's D minus 2 plus the sine of 2, isn't it? Alright, I gotta change this. Ugh. What's going on here? Alright, when in doubt, delete. Start over again. Alright, so this is going to take, I need the cosine of 2 times, I'm going to use the variable, subtract off 2 from that, plus the sine of 2. Oy. Technology is wonderful, isn't it? Hey, there it is. That's what we got in Microsoft Excel for the approximation. And this is just going to be the sine yeah, this guy's Now here it worked out pretty good. Here it's 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 pretty good. It's not bad. It's a pretty good approximation in this case. Excel had some issues. And I want to say Excel had some issues because it might not work well with the trig functions. So if you're dealing with trig functions, you might want to stay in a calculator, because then you can make sure it's in radians and everything's good to go that way. So it ended up being pretty good on that case. I would stay in the calculator. If you're at home, don't have a calculator, you want to do all those really fast repeated operations, then you want to use some type of spreadsheet